All right, so 9.2 is rate, ratio, and proportion. So we're starting off with rates. Rates is a comparison of two quantities, and it can be written as a fraction. So an example of that is 135 miles over 6 gallons, 135 miles per 6 gallons. So another word for that division is per. So we're talking about miles per gallon. So it lets us know we're dealing with miles over gallons. All right. So a unit rate is a rate in which excuse me, is a rate in which the denominator is one. So if we were to take that 135 miles over 6 gallons, or 135 miles per 6 gallons from the first example, go ahead and divide that. 135 divided by 6 is 22.5. So that means that would be 22.5 miles for every 1 gallon, or 22.5 miles per gallon. So once you divide that out and make that denominator 1, it is actually considered a unit rate. All right, a dental hygienist earns 1,304 for working a 40-hour week. What is the hygienist? There we go. What is the hygienist hourly rate of pay? So you want to know dollars per hour. So that's what you're looking for, dollars per hour. How much does he or she make per hour? So that you already know that's $1,304 per 40 hours. So if you want to know per 1 hour, for every 1 hour, how much that person makes, take that 1304, divide by 40, 32.6. 32.6, well, $32.60 for every 1 hour. So it can be written either one of those ways. All right. Questions before we look at another one? All right. All right. So which is the more economical purchase? An 18-ounce jar of peanut butter priced at $2.69, or a 20-ounce jar of peanut butter priced at $3.99. All right. So what we want to know here is the cost per ounce, or dollars per ounce. So that means when we set up our rates to do our comparison, we're going to have our dollars on top, our ounces on bottom. So the first one, we have 18 ounces, 18-ounce jar of peanut butter, and it's priced at $2.69. So it's going to be $2.69 on top, 18-ounce on bottom. So you divide that out, 269 divided by 18, it gives you 0.149. So that's 0.149 per ounce. X was 399 divided by 28 ounces. So 399 divided by 28. So that's 0.143 per ounce. So that means the 28 ounce jar would be the more economical purchase. Mhm. All right, so ratios, the comparison of two quantities that have the same units, can be written in three different ways: as a fraction, 2/3, used with a colon, 2:3, or with the word 2, 2 to 3.
Does that say revealed?
Yep, revealed. hmm On a survey revealed that on average, eighth graders watch. All right, so a survey revealed that on average, eighth graders watch approximately 21 hours of TV each week. Find the ratio as a fraction in simplest form of the number of hours spent watching TV to the number of hours in a week. All right, so they tell us to find a ratio. So that's where we're looking for calculation on how to set up the problem. So let's find a ratio as a fraction of the number of hours spent watching TV to. So that's the breakup of our ratio. So in other words, whatever's in front of 2 is my top number. Whatever's after 2 is my bottom number. So we're looking at the number of hours spent watching TV, which we know is 21 hours. And then on bottom, the number of hours in a week. So we know our top number, like I said, is the 21 hours. Now we need to make sure we know how many hours there are in a week. All right. So there are 24 hours in a day, and there's 7 days in a week. All right, so that's just 24 times 7. That should be 168 hours. All right. So the ratio that we're looking for is going to be that 21 over the 168. Remember, the number of hours spent watching TV as an eighth grader is 21 hours, and the total number of hours in a week is 168. So now we can break this down. 21 hours. And so 168 is 21 times 8. So 21 will cancel, leaving you with 1 in the numerator, and that is 1 over 8. 1 second. Oh, I hadn't started saying anything. I was just writing. All right. So a unit ratio is a ratio in which the number and the denominator is one, just like we talked about a unit rate. Let me make sure. Okay, cool. Um, so just like we talked about a unit rate, when the denominator is one, a unit ratio is also when the denominator is one. So starting off with this next example to give us a little bit of a chart, we have the university, two universities that we are discussing. We got Oregon State University and then the University of Oregon. The amount of men that are in each, we have 10,018, 8,849. Amount of women, 8,459, 9,824. Then faculty, 1,471, 1,364. All right, so we want to calculate the student faculty ratio at OSU, round to the nearest whole number, and then write using the word two. So we're looking for student faculty ratio at OSU. So what's going on at University of Oregon doesn't matter in this problem. So we know the total number of students at OSU. So it means we need to add the men and the women. So that's 18,477. Let's see, it's our total. And then, as notes has student first, then faculty. So if we were to set up a fraction, student goes first or on top, faculty on bottom. Faculty number for OSU was 1471. All right, so when we divide those out, we get 1256. Remember, they want us to round to the nearest whole number. So 1256 will be 13. Then they want us to write it using the word 2. So it's 13 to 1 ratio. All right, any questions before we look at the last thing in this section?
Can you scroll back up to the question for me?
Say that again.
Can you scroll back up to the question for me? All right, thank you.
No problem. Proportion is just a statement that says that two ratios or rates are equal. So, example of proportion is 2/3 equal to 12/18. So we will be able to check if we have a proportion or not, or the way we will be able to solve a proportion is by the cross products. It says if we have A over B equal to C over D, then we can do cross multiplication. Take your denominators up to the opposite numerator. In other words, take your D to the A, take the B to the C, and AD will be equal to BC. So if I look at it, 2/3 equal to 12/18. And we cross multiply. That would be 2 times 18 on the left, 3 to 12 on the right. 36 is equal to 36. All right. Questions on cross multiplication before we use it? All right. So 8/5 equal to n/6. And we want to solve. Cross multiply. So on the left, we have 8 times 6. On the right, 5 times 9, n. 48 equal to 5n. Divide by 5. Whoever sign will let you know what form they want your answer in. That's how you would do it. All right, so if you travel 290 miles in your car on 15 gallons of gas, how far can you travel on 12 gallons of gas under similar driving conditions? So the first thing you want to do is set up your proportion and be consistent in how you set it up. And what I mean by that is that You want to set it up the same way throughout your problem. So if you're going to use miles over gallon in one ratio, then you have to use miles over gallon in the other ratio as well. Remember, we have two ratios or two rates, knowing what you're measuring or what you're comparing. So here we're doing miles and gallons. So we have 290 miles off of 15 gallons of gas. So that's the first ratio. So if I do miles over gallon, when I set up my second ratio, I need to make sure I do miles over gallons as well. If I want it, I can set it up as gallons over miles. It doesn't matter. We just have to stay consistent throughout the whole proportion. So if I do 290 over 15, my other one, how far can you travel? So my mileage is X over around with 12 gallons of gas. All right. So we have 290 over 15 equal to X over 12. Cross multiply. So that'd be 290 times 12 on the left, 15 times X on the right. 290 times 12 is 3480. Now to solve for X, we'll divide both sides by 15. All right. So you can travel 232 miles on 12 gallons of gas. All right, let's do at least one more. We should be good to go. All right, so the dosage for a certain medication is 2 ounces for every 50 pounds of body weight. How many ounces of this medication are required for a person who weighs 175 pounds? So just like before, you have to make a decision how you're going to set up your proportion and be consistent. So if you're going to do ounces over pounds or pounds over ounces, it doesn't matter. Just make sure you stay consistent in what you're going to do. All right. So, and when we're talking about ounces, we're talking about ounces of medication, pounds of body weight. So we're looking at 2 over 50 as our relationship. Then how many ounces of medication? That's our X. And 175 pounds. So once you have your proportion set up, cross multiply. It will give us 2 times 175 on the left, 50 times X on the right. $350 equal to 50X. Divided by 50. We have X equals 7. So a 175-pound person requires 7 ounces of this medicine. All right. Questions, concerns, comments, anything about anything I've said before we look to close? Because if I'm not mistaken, chapter 9 only has one more section as far as what you guys are held accountable for. I believe that's the case. I'll check to make sure, and then we'll be leaving chapter 9, so I don't want to push it. Still trying to make sure you guys are straight with chapter 7, so we'll just do chapter 9 today, and then next class we will be looking to review. So make sure you bring your questions on next class. Before we close, any questions on today?
I've never seen. Generally, do you have any assignments?
Hold on. You breaking up. You got a lot of background. Say that again.
Do we have any assignments?
Yeah, your assignments are in WebAssign. When you go on the Blackboard, as a matter of fact, yeah, I think I stopped the sharing.